Welcome to another video by Team Matcom. In this particular video, we will be discussing a question based on the concept of law of conservation of linear momentum from the chapter Laws of Motion. Hope the video would be useful. If you need any clarification, do let us know in the comment section. The question is, a shell of mass 20 kg at rest explodes into two fragments whose masses are in the ratio 2:3. The smaller fragment moves with the velocity 6 meter per second and kinetic energy of the larger fragment. So we have a fragment of mass 20 kilogram, that is sorry, a shell of mass 20 kilogram that is getting exploded to two masses are in the ratio of 2:3. If it is a 2:3 ratio, we can write it as 2x and 3x. It is starting from the rest. The initial mass of the shell is 0. That means they are starting from the rest. Therefore, we can write it as u is equal to 0. They are telling that the smaller fragment moves with a velocity of 6 meter per second. So we can write it as v1 equal to 6 meter per second. We don't know the velocity of the larger fragment. We can write it as v2 is equal to, we don't know. So since 20 kilogram mass is split up into the ratio of 2x is to 3x, that means what? 2x plus 3x, that is 5x equal to 20. Therefore, x is equal to 20 divided by 5, that is equal to 4 kilogram. If x is equal to 4 kilogram, the mass of the smaller fragment is 8 kilogram and the mass of the larger fragment will be 12 kilogram. We know that according to law of conservation of momentum, so we know that the total momentum should be conserved. Total momentum should be conserved. Since total momentum has to be conserved, so what we can understand? So we can consider what would be the momentum before explosion. So the initial momentum will be equal to, we know that momentum is equal to mass into velocity. So initial mass, therefore that is equal to m into initial velocity, that is u. Initial mass is 20, velocity is 0, that is equal to 0. Momentum is mass into velocity, that is kilogram meter per second. Then what would be the final momentum? It is getting exploded to two components, So the final total momentum is equal to what? The mass of the first component, that is m1, into its velocity v1, plus second component into its velocity v2. That is equal to m1 is 8 into 6 meter per second, m2 is 12 into v2. Since total momentum has to be conserved, so initial momentum should be equal to final momentum. So what we can write? 48 plus 12 v2 equal to 0. That is 12 v2 equal to 48. Therefore, v2 is equal to 48 divided by 12. That is equal to, it should become negative. That will be equal to minus 4 meter per second. So minus 4 meter per second. So now we need to calculate the kinetic energy. We know that the kinetic energy is equal to half into mv square. Here it is a mass of the second component m2 into v2 square. That is equal to half into m2 value is what? 12 kilogram into v2 value is, v2 is minus 4. v2 square will become 16. So minus 6, v2 square will become 16. 12 and 2 will get cancel. You will get 6 here. Therefore, 16 into 6 will be equal to 96. So that will be equal to 96 joules. So the kinetic energy of the larger fragment will be equal to 96 joules. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.